Hey guys, today we have a nice easy lesson, operations with functions. Now we're going to be dealing with polynomials in these examples, but this works for any function whatsoever. So we're going to go over the basics, adding, subtracting, multiplying, dividing, and let's just take a look at this example here. We've got f of x is equal to 3x minus 7, and g of x equals 13 minus 2x. Notice the function notation. Make sure you remember what that's telling us. This guy's name is f, this guy's name is g. Both of them are based on x. That's your variable. It's telling us to find f of x plus g of x. So do it. Just take your f, this guy's name is f. So take f, put a plus sign, and add g. Now technically, this is f. Let's group it just to be safe. And this is g. So we're adding this expression, this g of x right here, to this f of x right here. Now, since we're adding, these parentheses are not really helping us out here. I'm just going to get rid of them. But if we were subtracting, then we need to distribute a negative. It just depends on what you're doing. But realize that you're adding or subtracting, multiplying or dividing the entire function, not just a piece of it. So make sure you use parentheses. And then, of course, we combine the like terms. And we get x and plus 6. Now we indicate this, we notate this in a kind of shortcut way. F plus g of x. And that's what this is. So literally all you have to do to add functions together is combine like terms. Now here's your notations. This is f plus g of x. Well, that just means that's exactly what we did, f of x. I'm going to add g of x to it. F minus g of x, this one you definitely want to be careful of those parentheses. We're going to take f of x and subtract whatever g is from it. Multiply them together, well, that means f of x times g of x. We use a solid dot here. That's a tiny dot, but it's a solid dot. That means multiply. Now here we're just dividing, so we do f of x divided by g of x. So that's just our 4 basic operations: add, subtract, multiply, divide. And you just treat it like a number. It's this thing over this thing if you're dividing. Be careful though, whenever we do divide, we're definitely got to be careful of our domain. Remember domain and range and all that good stuff? Well, it's back. If we're dividing by something, the denominator cannot be 0. So we'll have to check and make sure that that's not happening when we do these. So a few examples here. So we have 3 functions here. F is quadratic, G is a linear, H is a linear. Now find each function and indicate the restrictions. So if we're adding, subtracting, multiplying, or dividing a function, we're going to get a function out. We just have to be careful that we watch the domain. Easy enough, f plus g. So you don't have to write it out like this, but if it helps you to do it, then by all means do it. I'm just going to write it out. Here's my f. Plus, here's my g. Again, those parentheses, I'm looking at it. No, we don't need them. Get rid of them. You don't actually have to get rid of them if you don't want to, but they're not serving us any purpose, so I'm going to go ahead and get rid of them. Combine like terms. And hey, you're done. Now let's look at f minus h. So pay close attention to their names. F first. So this whole thing right here is f. minus h. Well, h is x plus 2. So this first set of parentheses is really not doing anything for us. It's just saying, hey, this is f. This next set, however, we are seeing that we need to distribute this negative here. So if you need to, you can write out a whole other step. If you don't need to, you don't have to. I'm going to go ahead and write it out so everybody can see it. If I distribute that negative, I'm going to get a minus x and a minus 2. So that's going to be x squared minus 9x plus 2. That's it. We're not solving for anything here. We're just doing some basic operations. You're not going to get x equals on these. You're not solving. It's not equal to anything, so you can't find it, but it's equal to. Same functions here. This says h times g. Here's h, here's g. Let's do it. H and times g. Definitely need to put those parentheses on this one. We are multiplying two binomials. We're using the distributive property here. So that's going to be 4x squared minus 3x plus 8x minus 6. Combine like terms. And there we go. Number 4. F of x over h of x. So let's see. X squared minus 8x plus 4 over x plus 2. And again, these parentheses aren't doing us really good. Now we just talked about dividing. You can use synthetic division, you can use long division. Heck, you might even be able to factor this thing. I'm not sure off the top of my head, but probably since we're actually trying to find it, it is factorable. Your choice on to what you're wanting to do. I'm gonna just do synthetic division real quick. I find it quicker and easier than anything else. So I'm gonna start by putting what makes my denominator 0 in the box. Writing down my coefficients. Making sure I don't have anything skipped. F over h. Yeah, so this one does actually have a remainder, so. So we're left with 24 as a remainder. So write it out. It was quadratic, reduce the power by 1, that's linear. X minus 10 plus 24 over our divisor, which is x plus 2. And that's the quotient. Now that we've done these first 4, let's go back and think. We also had to find what our restrictions were, right? Is there anything in the domain that I can't have? Well, this is a freaking polynomial. You can put whatever you want in it, right? Same thing for this one. Polynomials domains are all real numbers. Polynomial domain all real numbers. Oh, wait. Look at that. It's not a polynomial because we have a divided by x, which is x to the negative 1 power, if you remember. So this is not a polynomial. If we check, sure enough, there's something we cannot have. What can we not have here? X cannot be equal to negative 2. That's what's happening. Because if it was, well, that would be 0, and then we'd be dividing by 0. Can't have that. No can do. For all the other ones, these domains were all real numbers. So you can indicate that in neural notation. I'm not too terribly worried how you notate it. Just makes you realize what you cannot have if we're doing a division problem. That's the most important thing on this domain and range, is watching out for these division problems. Okay, let's check this one out. H divided by G. So that's x plus 2 over 4x minus 3. Okay. Synthetic division will work again. It's not going to be very interesting though. Hang on, let me see what they're trying to get at here. I'll be right back. All right, so I see what they're trying to do here. So if it doesn't simplify, it does have a remainder, you can leave it like this. Because next week when we get to rational functions, this is what we're going to be seeing. And this will actually be helpful. This is going to be our asymptote here, but we'll get there. We'll get there. So if it does have a remainder, leave it like it originally was. If it doesn't, then you can write it like this. And obviously, we don't have the remainder here. So right here, well, this is going to have a remainder. If I were to do the synthetic division on it, what makes my bottom 0? 3/4. My coefficients are 1 and 2. And yeah, this is definitely not going to work out for us, is it? That's 11/4 of the remainder, so you'd have a fraction on top of a fraction. It's not fun. But it's got a remainder, so leave it like it was. What's the domain, though? Everything except x cannot be, well, we just figured it out, 3/4. Now, f times g of x. If we're multiplying two polynomials, then we don't have to worry about the domain. It's going to be all real numbers. If we're adding, multiplying, or subtracting polynomials, we're good on the domain. But if we're dividing, that's when you got to check. All right, so I've got a helper here. We're going to do f times g. So again, here's f. And we're going to multiply that times g of x. So again, distributive property. X squared is going to everybody. Negative 8x is going to everybody. 4 is going to everybody. So that's 4x cubed minus 3x squared minus, now we're on this guy, 32x squared plus 24x.
Plus 24.
And then we do plus 16x minus 12. Now find out your like terms and combine them. I got some x squareds here. I got some x's there. Put them together. 4x cubed minus 35x squared
Mimi.
plus 40x
Go.
minus 12 minus minus, hang on, almost there.
Oh, it's almost there.
Minus 12.
Good.
And the domain is all real numbers. All right, guys, that's it for operations. Next up is composition. I'll get there in a little bit.